Hey guys, as we know, we're continuing with the playlist for CIE A-Level Maths, Pure Mathematics 1, paper code 9709. In this video, we're going to do everything that comes for integration in Pure 1. So that means integrating an equation of a curve, then finding the area between the curve and a line, between curves, and then finding the volume. So these are the three main things that come for integration in Pure 1. So let's start with this one and see how we can develop better understanding for this topic. And as you can see, we're using past paper questions starting from 2018 to 2025. So as you can see, the first type of question you get is to find the area of the shaded region between a curve and a line. So here it says the diagram shows the curve with the equation y equals to 5x to the power of 3 over 2 minus 20x, and the line with the equation y equals to x minus 16. So we have the equation of the curve and the line. The x constitutes the points of intersection of the curve and the line are 1 and 16. So this over here is 1 and this over here is 16. We have to find the area of the shaded region between the curve and the line. So as you can see, if you notice this line and this point over here, this entire region would be area of the curve. And if we subtract area of the triangle from it, which is all of this, we get the shaded region. So we use integration to find the area between a curve and a line, or between curve and a curve. So that's going to be integral of the curve minus the integral of the line. So the limit is from 1 to 16. So minimum limit over here, maximum over here. So 5x to the power of 3 over 2 minus 20x dx minus from 1 to 16 x minus 16 dx. So now we integrate both the equations. So 5x to the power of 3 over 2. So for integration, we add 1 to the power and then divide the term by the new power. So 5x to the power of 3 over 2 plus 1 divided by 3 over 2 plus 1 minus 20x to the power of 1 plus 1 divided by 1 plus 1. And this is from 1 to 16. There's a limit of 1 to 16 to this. When there's no limit given for integration, you add a constant, but since there's a limit given over here, we don't add any constant over here. Minus x to the power of 1 plus 1 divided by 1 plus 1 minus 16x from 1 to 16. Integral of a constant means that you add an x with it. So it's the opposite of what you do in differentiation. If you differentiate a constant, it becomes 0, but integral of a constant is that number written with x. So 5x to the power of 5 over 2 divided by 5 over 2 minus 20x squared over 2 from 1 to 16, and then x squared over 2 minus 16x from 1 to 16. Simplify this. This is what we get. And now we put in the limits. So we're subtracting the smaller value from the bigger value. So it's going to be 2 times 16 to the power of 5 over 2 minus 10 times 16 squared minus, then 2 times 1 to the power of 5 over 2 minus 10 times 1 squared. And then this minus for the other one. So 16 squared over 2. This is 2 minus 16 times 16 minus 1 squared over 2 minus 16 times 1. Let's see what we get. So for the first one, 16 is 4 squared. The 2's get cancelled out. So it's going to be 4 to the power of 5, which is 1024 times that by 2. That's 2048 minus 16 squared is 256 times 10 is 2005 and 16. Minus Then 2 minus 10, which is negative 8. And then for the other one, 16 squared divided by 2, 128, minus again 16 squared, that's negative 128. And then 0.5 minus 16, negative 15.5, so that's plus 15.5. Let's find the final value now. We're getting negative 391.5, but since the area cannot be negative, so it's going to be positive 391.5. That is the area of the shaded region between the curve and the line. Then again, it says the diagram shows the curve with equation y equals to 9 over 5x plus 4 to the power of 1 over 2 and the line y equals to 6 minus 3x. The line and the curve intersect at the point P, which has y coordinate of 3. Find the area of the shaded region. So if they're intersecting at point P, we can find the x coordinate of point P first. So we have y equals to 6 minus 3x. If the y value is 3, x value is going to be 3 minus 6 over negative 3. 3 minus 6 is negative 3, and we're getting x equals to 1, which means over here, x is 1. And as we know, the line is passing through the x-axis, so we can find this point by putting y equals to 0. So 0 equals to 6 minus 3x. 3x equals to 6, and x is going to be 2. Now, we find the area of the curve from 0 to 1, and then add area of the triangle from 1 to 2. Because they want to find area of the shaded region, so shaded region is underneath the curve. So we don't need to subtract the two areas over here. We just find the area of the curve from 0 to 1 and add the area of the triangle, this one, to it. So area is going to be 1 over 2 times base, which is 1. This is the base of the triangle, and the height over here, this was 3. Plus the integral of the curve from 0 to 1, 9 over 5x plus 4 whole power 1 over 2 dx. So what we'll do is, this is going to be 3 over 2 plus, for the integral, we will bring the bracket in the numerator. So the power becomes negative 1 over 2. Now we integrate this. So for the integral, you will add 1 to the power, divide the term by the new power, and then you take the integral of, and then you further multiply the denominator by the coefficient of x. So that's going to be 9 times 5x plus 4 whole power negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1. And this gets multiplied by the coefficient of x, which is 5. Limit is from 0 to 1. We simplify this, that's going to be 3 over 2 plus negative 1 over 2 plus 1 is 1 over 2, so that's 5 over 2. 9 divided by 5 over 2 is 18 over 5. Times 5x plus 4 to the power of 1 over 2 from 0 to 1. So that's going to be 5 times 1 is 1, 1 plus 4 is 9. Square root of 9 is 3, so 18 times 3 over 5 minus 18 over 5 times 5 times 0 is 0, 0 plus 4 is 4, square root of 4 is 2. So 3 over 2 plus 18 times 3, 54, minus 36 is 1805. So common denominator is going to be 10. So 15 plus 36 is 51. So 51 out of 10 is the area of the shaded region. So 51 over 10 is the area of the shaded region as given the diagram, which is between the curve and the x-axis along with the line. Then it is given that the integral of a over 4x minus 3 whole square plus 2 is equal to 12 for the limit of 1 to 3. We have to find the value of the constant a. So for this, let's bring the bracket in the numerator first. It's going to have a power of -2 now. Integral from 1 to 3. Integral is from 1 to 3 and is equal to 12. So when we integrate this, we know we add 1 to the power. Divide the term by the new power and times it by the coefficient of x. And the constant has an x with it, and it's from 1 to 3 equal to 12. So we substitute the value of 3 first and then 1. So a times 4 times 3 minus 3 to the power of -1 over -4 plus 2 times 3, and then minus a times 4 times 1 minus 3 over -4 whole power -1 plus 2 times 1. And this entire thing equals to 12. That's going to be 12 equals to 4 times 3 is 12. 12 minus 3 is 9. So a over -4 times 9 plus 6 minus 4 minus 3 is 1. A over -4 plus 2. A over -36 plus 6 minus 2 plus a over 4. 12 minus 4 equals to 36 minus a plus 9a. 8 times 36 equals to 8a. 36 equals to a. That is your value of a. Now the diagram shows part of the curve y equals to x squared minus 1 over x squared. The shaded region is bounded by the curve, the line x equals to 2, and the x-axis. We have to find the volume formed when the shaded region is rotated through 360 degrees about the x-axis. Give the answer correct to 2 decimal places. When you're trying to find the volume of a shaded region, when it is rotated through 360 degrees about the x-axis, the formula we're going to use is v equals to pi integral y squared dx. We're going to find the integral of y squared. We're going to find the integral of y squared and times it by pi. If you look at the diagram, they have given us the higher limit but not the lower limit. To find the lower limit, we put the equation equal to 0 and find the corresponding x values. So 0 equals to x squared minus 1 over x squared. 0 equals to x to the power of 4 minus 1. We multiply all of the terms with x squared. 1 equals to x to the power of 4. Find the fourth root of that, and that gives us plus minus 1. So this is 1. So our limits are going to be from 1 to 2. So v equals to pi 1 to 2, then y squared, x squared minus 1 over x squared whole square dx. So first, let's expand the bracket. X squared squared minus 2 times x squared times 1 over x squared plus 1 over x squared whole squared dx. X to the power 4 minus 2 plus x to the power of negative 4. Now we integrate this. X to the power of 5 over 5 minus 2x, x to the power of negative 3 over negative 3 from 1 to 2. Now let's find the numerical value of this. So it's going to be 2 to the power of 5 divided by 5 minus 4 minus 1 divided by 24. And then we subtract that from 1. And then we subtract the other limit from that. So 1 divided by 5 minus 2 minus 1 divided by 3. That's 4.49. Now we have to multiply this by pi, which is 14.11. That is the volume of the shaded region. Then it says find the exact value of the integral of 2 over x squared dx, but the limit is from 3 to infinity. So first rewrite this as a negative power 2 times x to the power of negative 2. Then we integrate this. So it's going to be 2 times x to the power of negative 2 plus 1 divided by negative 1 from 3 to infinity. Negative 2 over x is what we have. Now we substitute our upper limit first and then the lower limit. We know anything divided by infinity is going to be 0. So this is 0 plus 2 over 3. So the exact value is going to be 2 over 3. That is your answer. And since diagram shows part of the curve with equation y equals to 4 over 2x minus 1 whole square and parts of the line x equals to 1 and y equals to 1. The curve passes through the points A 1, 4 and B 3, 2, 1. Find the exact volume generated when the shaded region is rotated through 360 degrees about the x-axis. So the formula remains the same. V equals to, the formula remains the same. V equals to pi integral of y square with our limits over here. So over here, we have the lower limit and the upper limit is going to be 3 over 2. And we're rotating this part about the x-axis. Let's begin with writing down our equation. From 1 to 3 over 2, 4 over 2x minus 1 square whole square dx. So square this first. That's 16 over 2x minus 1 whole power 4 now. Bring the power in the numerator. It becomes negative 4. Now we integrate it. So 16 times 2x minus 1 whole power negative 4 plus 1 divided by negative 3 times 2 from 1 to 3 over 2. As we know, we divide by the coefficient of x and then we divide by the new power, which is going to be negative 3. So if we simplify this, what we get is negative 8 over 3 times 2x minus 1 whole power 3. Now we put in the limits. First 3 over 2. And then 1. And that gives us negative 1 over 3 plus 8 over 3, 7 pi over 3. So this is for the integral of the curve. As you know, when we integrate the equation of the curve, that gives us the volume of the entire part, like all of this. They just want the volume of the shaded region. So for that, we need to subtract this part over here, this cylinder, this rectangle part that's underneath. Basically, this part, we need to remove this. And to remove this, what we will do is, we will notice, so to remove this, if you realize when you rotate this thing, it makes a cylinder. And in that cylinder, this is going to be your height, the difference between 3 over 2 and 1. And as you know, when you find the difference of these two, that gives us a height of 1 over 2. And for the radius, which is this, that's going to be 1. So volume of cylinder is going to be, let's do that over here. Pi r square times height. 1 over 2 pi. So to find the volume of just the shaded part, we will subtract volume of the curve and the cylinder. 7 pi by 3 minus pi by 2, and that gives us 11 pi by 6. That is the volume of the shaded region rotated through 360 degrees about the x-axis. And it says a triangle is formed from the tangent to the curve at P, the normal to the curve at B, and the x-axis. Find the area of this triangle. So this is point B. Tangent at the curve at point B, normal at point B, and the x-axis. So this is the triangle. You have to find the area of this triangle. So to find the area of the triangle with the equation of the tangent and the normal, and for that we will use the equation of the curve. We'll differentiate the equation of the curve, find the gradient. Using that, we'll find the gradient of the tangent and the curve, and then make our equations. So y equals to 4 over 2x minus 1 whole square. So which is the same as 4 times 2x minus 1 to the power of negative 2. dy by dx is going to be negative 2 times 4 times 2 times 2x minus 1 whole power negative 2 minus 1. You first differentiate the power by bringing the power down, making it the coefficient, subtract 1 from the power, and then you differentiate the 2x in the bracket, which is 2. So you multiply that as well. So that's going to be negative 16 bracket 2x minus 1 whole power negative 3. Since we're talking about point B has a coordinates of 3 over 2 and 1. So put 3 over 2 in place of x and find the value of the dy by dx. Which is negative 2. So tangent equation is going to be y minus 1 equals to negative 2 times x minus 3 over 2, which is y minus 1 equals to negative 2 times 2x minus 3 over 2. The 2's get cancelled out. Y minus 1 equals to negative 2x plus 3. Y equals to negative 2x plus 4. That is the equation of the tangent. And for gradient of normal, that's going to be 1 over 2 y. because -2 times m2 equals to -1, so m2 will be 1 over 2. The tangent and the normal are at right angle to each other. So the product of the gradients is always going to be -1. So now equation of the normal, that's going to be y minus 1 equals to 1 over 2 times x minus 3 over 2. 2y minus 2 equals to 2x minus 3 over 2. Now 4y minus 4 equals to 2x minus 3. 4y equals to 2x plus 1. So y equals to 1 over 2x plus 1 over 4. That is the equation of the normal. So the tangent is also crossing the x-axis. The normal is also crossing the x-axis. The normal is crossing the x-axis at x equals to 1, which we can also cross-check. And we'll find the value for the tangent as well. At y equals to 0, for the first one, it's going to be 0 equals to -2x plus 4 and x equals to 2. And over here at y equals to 0, it's going to be -1 over 4 and x equals to -1 over 2. So if we again draw a rough sketch over here, this is our tangent, this is 4, this is 2, and then the normal, this is -1 over 2, and this is 1 over 4. So this is -1 over 2 and this is 2. The base is going to be 2.5. And we know over here point P is 3 over 2 and 1. Since the height is 1 and base is 2 plus half, so area is going to be 1 over 2 times 1 times 5 over 2, which equals to 5 over 4. That is the area of the triangle that is formed between the tangent, normal, and the x-axis. This is a curve which passes through 0, 3 has the equation y equals to f of x. It is given that the derivative of x equals to 1 minus 2 over x minus 1 cube. Find the equation of the curve. To find the equation of the curve, we integrate the derivative. So f of x would be integral of the derivative of f of x. So that's going to be 1 minus 2 over x minus 1, 3 dx. So you bring the bracket in the numerator, so the power becomes negative. That is the first step. Now we integrate this. We know integral of constant is going to be x. For this, we add 1 to the power, divide by the new power, which is -2, and then plus the constant, because there is no limit for this function. So x plus x minus 1 to the power of -2, which is x plus 1 over x minus 1 squared plus k. That is f of x. Now they've given us a point 0, 3. So when f of x is 3, x is going to be 0. Let's see what the value of k is going to be. That's 2. So f of x equals to x plus 1 over x minus 1 whole square plus 2. That is the equation of the curve. Then the tangent to the curve at 0, 3 intersects the curve again at one other point P. Show that the x-coordinate of point P satisfies the equation 2x plus 1 times x minus 1 whole square minus 1 equals to 0. So to find the point P first, We need to find the intersection between the tangent and the curve. So we're going to use the derivative to find the gradient of the tangent. So that's 1 minus 2 over x minus 1 cube. Substitute x equals to 0. That gives us 3. So that's the gradient of the tangent as well. So if you find the equation of the tangent, y minus 3 equals to 3 times x minus 0, y minus 3 equals to 3x, y equals to 3x plus 3. That is equation of the tangent. So we're intersecting this with the curve. So curve was y equals to x plus 1 over x minus 1 squared plus 2. Put this equal to 3x plus 3. Bring x into to the other side. Two x plus 1. Cross multiply. 2x plus 1 times x minus 1 whole square minus 1. So when you bring the 1 to the other side, it's exactly the same as the equation given in the question. So that's how we prove it. Then verify that x equals to 3 over 2 satisfies this equation and hence find the y-coordinate of B. Let's put it in the equation. Both sides are 0, so it does satisfy. So now for the y-coordinate of P, you put it into the linear equation. That's 15 over 2. That's the y-coordinate. Then it says the diagram shows the curve with the equation x equals to y squared plus 1. The points A and B lie on the curve. So we have the coordinates of both point A and B. We have to find an equation of the line AB. So very simple. Gradient is going to be 2 minus negative 1 over 5 minus 2. That's 3 over 3, which is 1. Y minus 2 equals to 1 times x minus 5. Y minus 2 equals to x minus 5, and y is x minus 3. That is the equation of the line AB. Let's just find the volume of revolution when the region between the curve and the line AB is rotated through 360 degrees about the y-axis. So if you notice in the previous questions, we only talked about the x-axis. In this one, it's about the y-axis. So now the equation is going to be slightly different. When you're rotating about the y-axis, it's going to be pi integral of x squared. So if you notice in the question, the equation also x equals to y squared plus 1. So our limits are also going to be the y values, and which are negative 1 and 2. So lower limit is negative 1, upper limit is 2. It's y squared plus 1 whole square. And this is going to be dy, not dx. So that's going to be y to the power 4 plus 2y squared plus 1. Now we integrate it. Y to the power 5 over 5 plus 2y cubed over 3 plus y from -1 to 2. And then -1. So that's going to give us 32 over 5 plus 16 over 3 plus 2 minus 1 over 5 minus 2 over 3 plus 1 times pi. So this is going to simplify to 78 over 5 pi. We have the line AB as well, which is y equals to x minus 3. So we're going to differentiate. So we're going to find the integral of this line as well. Then we're going to subtract the volume of the line and the curve to find the volume of the shaded region. We're rotating about the x-axis. So we're going to use x equals to y plus 3. So pi integral from -1 to 2 y plus 3 whole square dy. Expand the bracket. Integrate it. Then we put in the limits. Eight over 3 plus 12 plus 18 plus 1 over 3 minus 3 plus 9. So that's 39 pi. So volume of the shaded region is going to be the difference of 39 pi minus 78 over 5 pi. That's going to be 73.51. And with that, we're done with the questions for integration. If you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe and share this video with your friends. And don't forget to check out the other topics in Pure 1.